So before I start, just to reiterate, oh, there is a delay, isn't it? This is exciting. Yay. So the Slido, the questions are good for everybody, and the feedback is really valuable to the speakers as well. So there was a lovely quote in one of yesterday's talks from Niels Bohr. This is going to be dramatic, because I have a lot of slides. And if each slide ends up being... Right, I'm just going to stand over here and use the space bar. Right. One of the quotes in yesterday's talks was from Niels Bohr, and he said, an expert is someone who has found every possible way to fail in a small area. And I don't claim to be an expert, but I certainly have found a lot of ways to fail at Cloud Native. And as well, because I'm a consultant, so I work in the IBM Garage, and one of the things that we do is we go out and we help clients get to the cloud. And so I've done a lot of things wrong myself, and I've also seen clients do a lot of things wrong. And so between the two, I've got a pretty good picture of all of the things that you could do that might make things go wrong. So the first problem we see is the magic morphing meaning. And the problem here happens because we say, I want to be cloud native. Great. So what is cloud native? Ah, well. So if we have a group of people, and we ask them what cloud native is, everybody in that room is going to know what cloud native is. I'm sure every single one of you knows what cloud native is, to the point where it's hardly worth me even trying to describe what cloud native is. Except, so how many of you would say cloud native means born on the cloud? Show of hands. No, almost no hands. OK, I really like that one. So what about microservices? How many of you think it means microservices? No hands. OK, at this point, I'm coming to the conclusion that you're actually asleep. So how many of you think it means Kubernetes? Few shy little hands there. How many of you think DevOps? Few hands. What about just modern and nice and good? Yeah, some hands there. I think we often use that. We say we're doing it cloud native, and what we really mean is we're developing it like it's 2019 and not 2010. What I'm also starting to see is often, because we get such a strong word association now between cloud and cloud native, we often say cloud native when we just mean cloud. So how many of you think cloud native just really is a fancy way of saying cloud? One or two. And I'm starting to see this as well, because I'm starting to see people talking about migrating applications to be cloud native. And to me, that doesn't make a lot of sense. Just like I could migrate to Poland, but I could never be a Polish native speaker, even if I got really good at Polish. It seems to me that it's the same for cloud native, that you could migrate an app to the cloud, but it's never going to be cloud native. But it's maybe it's a useful way of thinking about it. OK, so how many of you think it means idempotent? One hand. And all of the rest of you, including me, are standing there going, idempotent? Remind me what idempotent means? I have this vague memory that somewhere back in computer science we talked about what idempotent means. So idempotent really is a fancy way of saying rerunnable. And so this is one of the really important things, that if you're going to be in the cloud, you're probably going to scale up, you're going to scale down, you're going to go away quite unexpectedly. And so you need to be able to behave in a way that tolerates all that. But ultimately, what we have is we have a whole bunch of different definitions of cloud native. And I know there's at least a whole bunch of other definitions in the room as well, because I think at least half of you didn't put your hand up for any of these questions. So either you've got another definition of cloud native that you're sneakily keeping to yourself, or you're asleep. But I'm going to choose to believe it's that you've got a different definition of cloud native. Does anybody want to shout out other definitions of cloud native? No, OK, asleep. So the problem with this is, it doesn't really matter that the same thing can mean lots of different things to different people until you want to actually implement it. Because then you end up in a situation where an organization says, we're going to go cloud native. And so someone starts writing lots of applications that were born in the cloud. Someone else starts just doing cloud stuff. And then the stakeholder comes, and they thought they were going to get microservices. And they look and they say, well, you said you were going cloud native, but I can't see a single microservice. And you failed already before you even got started, even though you didn't do anything wrong. So that can be a problem. We see another problem about goals as well, which is, why are we even doing this? Why do we want to do cloud native? And then to figure out why we want to do cloud native, we sort of need to backtrack a bit and think, well, why do we even want to do cloud? Cloud itself isn't a goal. It's cool, it's nice, but it's not a goal. Just like microservices on their own aren't a goal. So one of the traditionally, people went to the cloud, and it was for cost reasons. They said, my on-premise infrastructure is costing me a lot of money. If I go to the cloud, it will be way cheaper. I don't need to manage my hosting. Great. And then we realized that one of the reasons that it was saving us money was because on the cloud, we got this elasticity. If we were hosting things ourselves, we had to have enough hardware to support the maximum capacity. If it's on the cloud, we only need to pay for the minimum capacity, and then we can scale up and down. So that brings a big cost saving. Another really, really big benefit of the cloud has to do with speed. So that means a few things. One is that things just generally go faster on the cloud. The hardware itself is faster, but that's not the main thing. The main thing is about how we can deliver software. We can get software to market faster, which means we can be more innovative. We can do things that we couldn't do if we were restricted by what we put in place around on-premises. And then finally, one of the cool things about the cloud that we're starting to see is that you can get hardware in the cloud that it wouldn't be practical to have on your own site. So for example, GPUs. You can have, a small number of GPUs on premises, but you're not going to want to have enough GPUs to do really serious machine learning on premises. But in the cloud, you can just go and say, yep, give me all these GPUs. And there's other processors as well that are optimized for machine learning. And if you were paying attention yesterday as well, one of the things that we now see on the cloud is quantum computers. So there's all sorts of reasons that you wouldn't want a quantum computer on premises. One of them is that you need to keep it colder than the space between the stars. But on the cloud, you can have someone else's quantum computer, which is cool. This is a new one, but it used to be when we said, I'm going to the cloud, people would say, well, OK, I can see it's going to save you money, but think about security. As soon as we go outside our own firewall, things are really terrible. The perception is shifting a bit now because there's a whole bunch of security capabilities that you can only get in the cloud. So actually, cloud can be more secure than on-premises in terms of the dynamic checking and how you can sort of build security in. So all of this is good, but it still leads to the prospect of misunderstanding again. Which is that, if we go to the cloud and our stakeholder says, thinks we're going to get faster time to market, or our stakeholder thinks we're going to be using a quantum computer, and in the end, all we did is save money, well, that's maybe a really good result, but not if it's not what they were expecting. I like this one. This is the not actually continuous integration and continuous deployment. So I talk to a lot of customers, and they say, we have a CI/CD. And I'm kind of thinking, CI/CD, that's something you do. It's not, OK, cool. It's not like a tool you buy. You can't buy a CI/CD system and then continue to not be continuous and call yourself continuous. And so I hear phrases like, I'll merge my branch into our continuous integration system next week. And, CI/CD, CI/CD, CI/CD. And then, there's all this continuous. But then they say, and we release every 6 months, but we're doing CI/CD. And it's like, well, if you release every 6 months, I really don't think you're doing continuous integration and continuous delivery, which brings us to continuous. I don't think that word means what you think it means. And of course, it's easy to be judgmental, but there is actually some sensible questions that you can ask about how often you should be releasing, how often you should be integrating, and what is practical in terms of being continuous. So if you think about how often you should push to master, which is basically just saying how often should you integrate, well, there's sort of a spectrum. So at one end, if you wanted to be fully ultra-continuous, you could push every character. That would be totally continuous, but it would be a really stupid way of doing software development unless you were the only person in your team, because every character would cause chaos for all of your colleagues. So, you can be too pure on continuous integration. But, there's a spectrum beyond that. So you could do every commit, and hopefully you're doing frequent commits, so hopefully that's several times an hour. You could do every few commits, and so maybe once the commits make a little sensible set of function, and that's several times a day. You could do it once a day, maybe at the end of the day. You could do it once a week, starting to get a bit less good. You could do it once a month, and you could do it once every 6 months. And this sounds like a joke, but when I first started my software development career, and I should say as well, this was about 20 years ago, so it's not like this was, recently. The colleagues I worked with, they said, right, and so the best practice for how you manage integrating your work with everyone else is that you don't want to break the build. Because if you break the build, you end up on the build call, and this is a big worldwide call. That's bad. So the way we do it is we save up our work locally for 6 months, and then we only commit to master once every 6 months so that we don't get on the build call except for once every 6 months. So it sounds ridiculous now, but that is how they used to work. So there's this idea of trunk-based development, and trunk-based development is a good thing. And then the question is, well, how often do I need to be pushing to master for it to count as trunk-based development? And most things I've read say at least once a day. So if you're not pushing at least once a day, you're not doing trunk-based development. So if you're less than once a day, well, that's okay. If you're more than once a day, you're going to start to see a lot of problems in terms of whether you can do opportunistic refactorings, that kind of thing. So, anything more than that, bad. And then once you get to every 6 months, it's like, really? My personal preference is somewhere between every commit and every few commits. So then the next question is, how often should you release? Which is really, again, going back to what the D in CD is, that's, are you doing continuous deployment? And there's a similar sort of spectrum from, you could release every push, and that would be several times a day. Some companies do this. They have really strong automation to support that. Or you could do it once every 2 years. Some companies used to do that. They had very weak automation to support that. And so if you're going to do every push, then there's a whole bunch of technologies that you really need to have a good handle on in terms of feature flags, that kind of thing. And then, if you're going to do once a sprint, that's probably okay. Once every 2 years, that's old school. Once a quarter is still pretty common. It makes me a bit sad. Every epic, that's cool. Every user story, that's kind of, I think that's nice. And then, you're pretty hardcore if you're doing it. So when we talk about the CD, that can be continuous delivery or it can be continuous deployment. And when we say delivery, what we really mean there is testing and staging. So how often should you test and staging? And for this one, I think actually there really is only one right answer, which is that every push really ought to be tested and staging. So, you need to get the automation in place. And so why is there a gap between that testing and staging and actually releasing it? And we see this all the time. The number of customers I talk to, and they say, well, we can't actually release this. Well, you wrote it to release it. Why can't you release it? What's stopping these more frequent deploys? And microservices often end up being part of the problem, even though they're supposed to be part of the solution. So we'll have a whole bunch of microservices, and one of them's ready to go. Great. Microservices allow us to release independently. Oh, no, 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 no. We release all our microservices at the same time. Well, that's not really microservices. That's a distributed monolith, but we'll come back to that. But often it has to do with how we manage our customer expectations as well. That we say, we can't ship until every feature is complete. Well, this causes a lot of business problems. So there's this saying, if you're not embarrassed by your first release, it was too late. And the whole reason that we're doing the cloud, or one of the main reasons of doing the cloud, is to get this better, faster customer feedback, because we know that's really good engineering. So what's the point of architecture that can go faster if you don't go faster? And you would never drive a car like that. And yet, we don't always optimize for feedback cycles in our engineering. Even though feedback, it's good engineering, so it's good business. And there's a whole bunch of techniques that you can use when you release to make the releases a bit less scary. So, you can not wire things in so they're out in production, but no one's using them. Or they can be out in production, but only a few people are using them because you've got a feature flag. You can use A/B testing. You can use canary deploys. You can have things rooted so that only your employees see them. And all of that does give you that feedback from production, which is one of the reasons you went to the cloud. Another problem I often see is the locked down, totally rigid, totally inflexible cloudy cloud, uncloudy cloud. And so organizations put these processes in place to manage risk. And they made a lot of sense 20 years ago, but they just don't make any sense anymore. So I've had things like, well, the architecture board meets to review something a month after the project was scheduled to ship. And so then two bad things happen. Either it's already shipped and the architecture board is just a waste of time, or it was ready to ship, we had all of this value sitting on the floor, and yet it didn't ship. We had a client tell us, we'd sold them some really nice provisioning software, and they came back and they said, oh, the software you sold us is totally broken. And when we investigated, what we found was that we sold this nifty software that would give them a 10-minute self-service provisioning of clouds. But what they were seeing was that it would take 3 months to provision things. We thought, oh, this is totally broken. When we investigated, it turned out the reason was that there was an 84-step pre-approval process before anything could be provisioned. So the technology was working, but the process wasn't. And so what these organizations are doing, and what a lot of organizations do, because it feels like the safe thing to do, is you take the cloud, excuse me, sorry, I should have had more honey on my breakfast cereal. You take the cloud, and then you put it in a cage to make sure that nobody can actually access the cloud. And then, you do need to have some access. So you have a gatekeeper monster. And the way you keep the gatekeeper monster happy is to just feed the gatekeeper piles of paper until it lets you access the cloud. But, this isn't going to work. This isn't going to give the benefits of the cloud. And sometimes the way that organizations try and get around this is kind of odd. So we had a client, and they told us, oh, yeah, we're going to switch our cloud provider. We're like, oh, okay, right. Why are you switching? Well, the problem that they were trying to fix was that it took them way too long to provision clouds instances on their old one, because their procurement process had put in place all this stuff around it. So what they said was, well, if we go to a new provider, that's going to give us a better procurement process. And I was like, well, I'm not sure it really will, because I think what's going to happen is that you're going to end up with the same structures in place around the new provider within a few months. So maybe the better solution is to fix procurement rather than continually switching cloud providers. But really, ultimately for cloud native, if the developers are the only ones changing, it's not going to work. There has to be a change through the whole organization. So having said that too much governance is a bad thing, of course, you can get the opposite problem as well, which is that the cloud, it makes it so easy to provision hardware. But that hardware still has a cost. And just because you can provision it doesn't mean it's useful. So I had I had a problem when I was first learning Kubernetes a few years ago. I was putting it in place for a client project. And so I created the cluster, and it was quite a large cluster. And then I got sidetracked and pulled onto another project, so I forgot about the cluster for 2 months. And then I went back and looked at it, and I realized that it was costing £1,000 a month for this Kubernetes cluster that wasn't doing anything for anyone. So then I had a really awkward conversation with my manager to sort of say, oh, sorry about that. And you know, we see this where you can provision something, and then you go on holiday, and there's just money, going up into the sky, and it's not actually doing any good for anybody. And there's this idea that the cloud makes things really efficient, but if you're doing something that isn't useful with great efficiency, that's not useful, that's actually worse. And there's sort of a stupidity aspect to this and a waste aspect to this. But of course, there's a big ecological aspect to this as well now, that if we provision all of this cloud hardware, and it's just sat there using electricity, but not giving any benefit to anybody, that's pretty destructive. Another problem organizations often have is that they don't have any visibility of how much they're spending on the cloud. Because, with one cloud, it's okay, you can just look at the console and you can add it up. But a lot of organizations will have a lot of Kubernetes clusters spread out. They might have shadow IT. They probably have several different cloud providers. And so then to get a coherent picture of how much it's costing, nobody really knows. And so we end up with this sort of interestingly recursive situation, which is that you need a cloud to manage your cloud. Because clouds are actually really good at managing clouds, and you can get software to do it. So for example, we've got the IBM Multi-Cloud Manager, and that I don't think anybody will be able to read that, but you can see it's giving you the monitoring, and it's showing you how much you're using on each cluster. And some are in Azure, some are in AWS, some are in the IBM Cloud, and they're all presented together. So you do need this kind of coherent view, and you do need as well some sort of artificial intelligence to start managing the cloud. So with that, I think I'm out of time. So I only got through 6 fails, but I'll leave you with the cloud native spaghetti as the last fail. Because when we go to microservices, we're distributed. And that's really good. But distributed is not necessarily the same as decoupled. So we shouldn't confuse those two. So with that, I will leave it. Thank you.